Greetings, people of the interconnection. I am Justen. I compile the stories of the automaton. I hope you are doing well. To those of you who have come to this video from the stories of the automaton, I am loath to admit that this is not a story of the automaton, and I apologize. This is a programming blog. It has been decided for me to make this because I often field the question of where I learned to program. My usual response is in the form of a question. I ask my conversational partner what the thing is that I can never remember the name of. It's like a game where you're given a story, but some of the words are missing, and so you have to fill in the missing words before you can complete the story and then read it. And then they tell me oh, you mean like a Mad Lib? And then I'm like, yeah. The way that I learned to program was by writing Mad Libs programmatically, or just procedurally generating sentences more generally. So that's what we're going to be doing today. We're going to be generating random sentences. The framework that I'm going to be using is there's two ways of doing it. When you have a phrase structure grammar introduced by Noam Chomsky, you can either do it according to a dependency relation, like a verb points to a noun on the left side of it, and a verb or a verb phrase on the right side of it. We're just going to do it this way because then I can name more things and I think it'll be a little easier, but I'm not sure. So here we have a JavaScript file, and over on the right side of it, oops. Oh, I can't use my editor. Okay, over on the right side of it, we'll have just a terminal that I'll be able to run my program from. So here we can see that this JavaScript file is invalid JavaScript because it's just English. But anyway, to procedurally generate random sentences, what I would start out with is a list of nouns. So we might have cat, dog, person, government, and then we would have a list of adjectives, which would be good, evil, bad, terrible. And then we would have a list of verbs potentially. So we're going to stick to just the base form of the verbs for now. So we might have attack, eat, sit. Let's not do sit right now. Let's also do destroy, so we can continue in the same vein as attack and eat. They're similar-ish. Anyway, going back to the constituency relationship here, we want to be able to start with a sentence. A sentence is at the top of our file here, and then we'll try to work our way down. Okay, so let's start by making a function called makeSentence. So I'm going to try to use the same abbreviations that they use. Whoa, is my cursor showing up twice? That's kind of cool. Where they have sentence, noun phrase, verb phrase, etc. So instead of it being make sentence, I'm just going to do make s, because that's nice when I have to type less, right? And this won't take any arguments because it's going to try to make a random sentence. So just to remind myself that this is a sentence when I'm looking at it later, I'm going to give it a type S. The capital S stands for sentence, which will hopefully be unique, and it is going to include a noun phrase on the left side of it, and it is going to include a verb phrase on the right side of it, and that's according to this constituency relationship. So in order to do this, we need to make another function to generate a random noun phrase. So a noun phrase is going to consist of a determiner and a noun. So here we can see that it has a determiner and a noun inside of the noun phrase. So we'll call our determiner D, and we'll sample our big determiners array to get that determiner, and then we'll do the same thing for the noun, which will be just called n. So now when we make a noun phrase, we'll get a random determiner with a random noun. Yeah, and then we can call make np for the noun phrase in our make sentence function. And then we have to do the same thing for our verb phrase. Okay, so going back to our constituency relationship, we can see that a verb phrase ultimately will consist of a verb and then another noun phrase, or at least in this case that we're dealing with currently. So like if you have like attack, right, you would have like attacks the boy, or like attacks the dog, which would be like the verb phrase, and then on the other side of it, on the left side of it, you would have the original noun phrase, which would be like a cat, or like the dog, like I mentioned earlier. So for the verb phrase, we'll have a verb, just v, and that we'll get just by sampling our verbs array. And then our noun phrase, we can use our make noun phrase function that we made before to get a random one. And so we can see when we call this make sentence function, then right, we get this JavaScript object, this nested JavaScript object, which is representative of like a tree, a constituency relation tree, where like the top level element is an S, right, like this S here, and then we have a noun phrase which is on the left of the S, and then we have a verb phrase which is on the right of the S. So this is the NP and then the VP, and then it goes down until we hit the nouns, right? So here we hit the determiner A and the noun cat, etc. Right? If we run this multiple times, we can see that it always gives us a new random constituency relation. Okay, it's not very useful, however, to have these as our sentences, because usually when we read sentences, we read them, you know, like sentences. So let's try to see if we can make them into like a string. So let's write a function called toString, and that's just going to take a sort of a dependency relation, or like the tree structure that we just made, right? So here they, for shorthand, called it a PSG. I don't know what PSG stands for, but maybe we could just call it like N. N would be short for like node, so like the node of a tree. So if we had like a switch statement, and the node of the tree would have like a type, right? So if we gave it this S object, it would find the type S on it, and then we could make a case for that S type. And so what we would want this to do then is, since on the S we have a noun phrase or an NP on the left and a VP on the right, we could just recursively call this toString function on that. So we could do so we're getting the string of the noun phrase and the string of the verb phrase, and then we're just going to join them together. And then we could handle that case here. Let's put a default where we throw, just so we know that we're not finished yet. We'll always have to return in these. So a noun phrase is going to have a determiner on the left and a noun on the right. So that would give us n.d and n.n, and then we're going to join those together. And then similarly for a verb phrase. Verb phrase has a V on the left and an NP on the right. So we'll do n.v, and then on the right we'll do n.np, and then we'll join them. The problem being that this NP is an object, but since we already handled the case here, we should just be able to call the toString method on it recursively. So now when we call toString, whoops, on this makeS function, we should get a sentence. A dog destroy the government. A dog destroy a cat. A dog attack a cat. So we still have one little issue. This verb here, since it is the base form, it does not fit with the noun that precedes it, right? It is supposed to have an S after it, right? We're supposed to, what's that called? Where we conjugate? We have to conjugate the verb. So, since all the nouns that we're using are like third person verbs, they should just have like an S applied to it. There are certain cases where that won't be true probably, but we're not dealing with them, so we'll forget about it. In any case, what we can do is we can just append an S right here, at least for now, and then that should solve our problem. Yeah, a person attacks a person. A government attacks the cat. There's one more thing that we need to do here. We need to make this sentence have a capital letter and a period at the end. So to do that, we'll just add a function here to capitalize. So it's going to take a string, and we can use the slice method on strings. When given 2 arguments, it takes a substring of the string used, and we'll call to uppercase on that. Strings also have a method called to uppercase on them. And then we're going to append the rest of the string to it. So if you give it 1 argument, it'll slice off whatever number of characters that first argument is, and then it'll give you the rest of it. So this will give us the first letter uppercased, and the rest of the string will be the original string. And so what we'll do here is we'll just call capitalize on this first argument when we toString our sentence, and then we'll just add a period to the end, and then that'll give us the random sentence that we want.